to session 4. In this session, we will be going over layers, properties, and how we find out information about these different QGreenland data layers in QGIS and the different kinds of data layers that you can use. Let's choose the Places layer as an example. I'm going to turn on our Places layer group and then turn on the Towns and Settlements layer. As you can see, there are a bunch of little dots. And as you zoom in, you can see the names of everything. If I click on Towns and Settlements in the Layers panel and right-click on that layer, I'm given a menu of options. I'm going to scroll all the way down to that last option called Properties. When you click on Properties, it opens a window of layer properties with lots of different tabs for options of these various properties. To explore these properties, start at the top here in this Information tab. In this Information tab, you can see all sorts of things, such as the name of the layer, the geometry, and the CRS, which stands for the Coordinate Reference System. This will list what the projection or the coordinate reference system for that particular layer is, the full extent of that layer, the geographic area it covers in our particular coordinate reference system, and all sorts of other information. So for example, where did we get this data set from? We pull QGreenland datasets from a variety of credible sources, and those sources are listed in this Information tab. It also should have an abstract of that dataset as you scroll down. Another important place to find associated information is in the Metadata tab. The QGreenland team encourages you to be familiar with these metadata. When you use data for publications, making maps, and research, you should cite QGreenland and also cite the individual dataset source, which you can find in the Metadata and Information tab. There is also in this Layer Properties window a Symbology tab. The Symbology tab is just how data shows up in the map view, and so in this case for Towns and Settlements, the symbology of the Towns and Settlements layer is a simple round white dot. Before we move on, let's review the two main types of datasets you will find in QGreenland. The first type of data layer is called a vector layer, and these are things that are either discrete points, lines, or polygons. The Towns and Settlements layer is a vector point layer, meaning that the different data sets are all individual points representing the different towns and settlements in Greenland. The second vector data type you'll find in QGreenland is the vector line layer. Let's look at land streams as an example. All of these lines show individual streams around Greenland. The third type of vector layer is a polygon layer. These are all pretty intuitive based on what they're called. For example, let's look at the layer of bird protected areas in Greenland, which is a polygon that outlines a particular area. These individual polygons outline individual bird protected areas and agreements. So to summarize, vector layers are discrete points, lines, and polygons. There are data tables associated with these datasets, which we call attribute tables. And that's where all the information that we've attached and associated to that dataset lives. Let's get back into QGIS and QGreenland and turn off the Towns and Settlements layer. I'm going to turn on a layer that lives within our geology layer groups. To do this, I'll open up that geology layer group. I'm going to turn on that main layer group because I'm interested in this data set here called earthquakes with the magnitude above 2.5 between 1900 and 2020. I am going to toggle on the data set that shows all the earthquakes that have happened in this area that are a magnitude of 2.5 or greater. What you'll notice is that this layer has a particular symbology to show these earthquakes as dots. As a point vector layer, the size of the dot and the color of the dot gives you the different information. When you look at the layers panel, the size of the dot and the color of the area are related to magnitudes. The larger and darker the color, the greater the magnitude. To access the attribute table for this earthquake's point vector layer, I'm going to click on it and highlight it in the Layers panel. Then I'm going to right-click on it and access that Layer Properties window. I'm going to select the Open Attribute Table. This is the attribute table for the earthquake's layer. There's everything from the magnitude of each individual earthquake that's included in the dataset, like where it occurred, the date and time that it occurred, and all sorts of other information. Each of these columns is a different attribute, and each row in this table is a different event or earthquake that has happened. Here is a trick for finding out more information or attributes for different data. Let's say, for example, that we're interested in what the attributes look like for a particular earthquake. I am going to zoom in over here to the west side of Greenland. There's a larger dark red earthquake over here I am interested in. What if I wanted to know what the magnitude was and other attributes for that individual data point? Let's go to our Attributes toolbar. If you don't see a set of buttons, then that means your Attributes toolbar isn't toggled on. So go ahead and toggle that on. In the Attributes toolbar, you'll see this little information circle symbol with a mouse, and that's called Identify Features. If we toggle that on, and then we click on the data point, that's going to help us see all the attributes for that particular data point. You'll notice that they show up in a new panel. For me, it's over on the right-hand side, but it might be different for you. This is called Identify Features. Click on that point and it shows you the record of that attribute table for just that one data point instead of all of the individual data points in that data set. Let's talk about the second type of data layer you can find in QGIS. This is called a raster layer. Instead of being discrete points, lines, or polygons, raster layers are continuous data layers. This means that they're composed of pixels or rows, grid cells of a certain regular size that are all organized in a grid. The smaller the grid cell, the higher the resolution and smoother that data set will look. Here are 3 examples from the QGreenland data package to show you the different kinds of resolutions. In each of the raster layers in QGreenland, we always make sure to associate a resolution with it. This tells us that in the permafrost probability dataset, the grid cell sizes are 10 kilometers by 10 kilometers. It's a pretty coarse scale. The second example is another dataset from QGreenland called geothermal heat flux. This is a 5 kilometer grid, so the resolution is smaller. The tint looks a little bit smoother, but you can still see the individual pixels if you look hard enough. The last example is Greenland Image Mosaic 2019 10-meter resolution, which is a much higher resolution. All of the satellite images in QGreenland are raster datasets with a small grid cell size. Since they look very smooth, you would not even know that they are made of grid cells. So in QGreenland and QGIS, how do you tell the difference between a raster layer and vector layer? That's pretty easy to do. Let's open up some of these group layers. You'll notice that if you look at the dataset that are listed in the Layers panel, each of the individual data layers has a little symbol next to it on the left side. For the point vector layers, they can be identified by a small set of 3 points. The polygon vector layers are identified by a polygon shape, and the line vector layers are noted by a line. Raster layers are always indicated by this square that shows individual grid cells or pixels within it. Underneath, in the Regional Climate Models layer group, if you open up all RACMO model output layers, you'll see a lot of different raster layers, and they're all indicated by a symbol next to them. There isn't an attribute table associated with raster layers like there are with vector layers, and the reason being is that there aren't any discrete data layers like the vector layers. Raster layers still have a properties box that you can open and look at. Let's open the layer properties box for the snowmelt layer, and I will show you how to change the symbology of a layer. You can change the symbology of any layer no matter if it's a vector layer or a raster layer. The way to do that is to go to the Symbology tab. If you click on Symbology, you will see the current symbol for that layer. This shows the color ramp that we chose for this particular layer. Once you change it here, the way to make it appear on the map is to click Apply. This will change what the symbology looks like. After hitting Apply, press OK to make those changes stay. That's how you change the symbology of a raster layer, and the way you can change the symbology of a vector layer is the same. Let's open up the Common Mirrors Colonies layer. Right now, the symbology of this layer is just orange points. But again, I can change that by right-clicking on that layer, going to Layer Properties, and going to the Symbology tab. I can change the size of the dots here, and I can change the color of them. Let's do another practice task to explore data layers.